All right. Hello, chemistry class. This is going to be my first screencastify. This is my first video. So do not make fun of me if or possibly when I mess up. But we're going to go over significant figures today. So before you guys talked about scientific notation, again, scientific notation is just going to provide a convenient way to write, very large numbers and very small numbers in a way in which we can read them. All right. And so you guys have taken algebra before. You guys have taken the different classes before, so you know that dealing with the exponent, 10 to the whatever, you're just dealing with the placement of a number. Okay, so only you're going to see one non-zero digit written before the decimal. So again, one digit to the left of it, and then usually what you're going to see is at least one, maybe two. Decimals after that, but again, it depends on how the significant numbers work. And again, we're going to get into that later on. But again, the A is going to represent some number, 1.2, and then you're going to do times 10. So essentially, going down, it's going to be 1.2. You're going to move over two places. It's going to be 120. Okay. Let's see. I could probably make it cooler. Now we won't worry about it. So we again, understanding all this, scientific notation is going to be that 1.2 times 10 to the second power, and then the standard notation is how it is without that scientific notation, like 120 or like 1,254. So again, we're gonna kind of gloss over it. But when the exponent is positive, you're going to move the decimal to the right. Each one's going to be 1 over, so like 2 would be 2 decimal places, 3, and so on. Negative, you'd be moving to the left. So again, going from standard notion to scientific notion and vice versa, this is what we see here. And now we go into significant figures. So when we talk about significant figures, again, it's all the known digits plus the estimated digits that are significant. They're not placeholders, okay? And so what is known is going to be, for example, this 5.73, right? So when we measure the volume of a cylinder, on the last slide, we got 5.73. So the 5.7 is for sure. We know that, but the 3 can be, if it could be off by 0.01, so it could be 5.74, 5.72. It's going to be in that range, but we're going to estimate it's at the 3 mark. And so looking at the numbers there, we're going to know that the 3 are going to be significant, okay? And so we know it's significant because all 3 of them are going to matter. So if we're looking at this example here with the cylinders, graduated cylinders, we're going to see that, this is marked off by 100s, right? So, each 10 is going to make up 100 milliliters. And so on the left, we see is that we have an approximation, right? We don't have the lines there to give us a really close estimation. So on the left, we see 120 mils. And so we think it's in the ballpark of 120, but, it's around there. We're not really sure. And so that's when you look at this number here. Why isn't it working? Whoops. All right. Well, let me write. But when we see this number here, it's not, we don't see that decimal point. So we don't know if it's going to be for sure. But with the lines, we have a better idea of what it's going to look like. So we could put the decimal point there. We know it's going to be at 120. But the thing is, we don't see any numbers afterwards because we aren't exactly sure how close the measurement's going to be. So if it's 120.00, well, we know it's going to be exactly at 120.00 milliliters. But if it's 120.12, well, then it's more exact. Then we have a better idea of what it is. So We can't be that specific, but we do know for sure it's going to be at least at 120. Where at the 120 at the left, we know it's in that area. So when we look at the significant figures for this one, on the left, we're only going to get 2. So this is 2, while this would be 3. All right, moving down. So again, zeros to the right of the non-zero digits are going to be significant, but only when there's a decimal present, right? So for example, we have 12.00 meters. We know it's going to be exactly at 12.00 meters. So we know it's going to be 4 significant figures. 1200 with that decimal point here, decimal point there, you're going to see it's still significant because we know it's going to be exactly at 1200, but we don't know if it's closer to 1201. We don't know if it's going to be 1199, but we know it's for sure 1200. It's not going to be 1201. It's not going to be 1199. Okay, but without that decimal, we know it's at 1200. We know it's for sure there, but it could be 1201. It could be 1199, and that's the idea here. That since I skipped. Since it's around that area, this 0 here is going to be insignificant. We don't know exactly, but that decimal point helps us out. And so even with this 1.20, we know that all 3 of them are going to be significant because we know that's going to be for sure. Okay. And then counting numbers and defined quantities have unlimited significant digits. So 3 gold atoms, that's going to be significant. 1 hour, 60 minutes, that's going to be significant. Again, those are going to be unlimited because we know that's defined. We know that's for sure, right? We don't have to say 3.000000 gold atoms. No, we know it's for sure 3. But it would take a while. It'd be 10 to the infinity. We don't need that. Same thing with the 1 hour, 60 minutes. We know it's exactly that. Going back to his slide, the significant figures rule. Every non-zero digit is significant. Right, so unless there's a 0, all the numbers are going to be significant. If zeros are between non-zero digits, then we know that those are going to be significant also. But the thing is that zeros to the left of a non-zero digit are not going to be. So when we look at this example here, 0.01, we know that the 2 zeros are going to be insignificant. We're only caring about that 1. Same thing with the 0.000056. We only know that the 2 are going to be significant because there's not a non-zero digit right here. Okay. And then we went over this. So an answer cannot have more significance than measurements upon it, which it is based. Your answer is only as good as your worst measurement. And what they're really saying here is that, the more significant digits you have, the more accurate it's going to be, right? So example, if I was measuring, let's say, the mass of sugar, if I were to say 34 grams, well, it's 34, but there's a possibility that it could be 34.5, 30.4. It's not exactly 35 grams. I didn't state it. However, if I were to be like, oh, I know that my amount is 35.04 grams, then I know it's exactly 35.04 grams. Now, it could be 35.041 or 35.042, but we know that the 4 significant ones are the 35.04. And that's what we're looking for here. And so looking at this, we know, looking at the significant figures, that the 2 non-zero digits are outside of the zeros. So all these numbers are going to be significant. We know that this is going to be significant because there's a non-digit or non-zero digit to the left. So everything after that, especially after the decimal point, is going to be significant. So 3.000. We know that it's going to be that exact measurement, so that's 4. Since there isn't a decimal point here, we know that after the 3, that these are going to be insignificant. But since there's a decimal here, we know that that will be, so that's the difference between having 1 sig fig compared to 4. We see here that in the scientific notation, that since we have the to the 2.30, that everything after that decimal point that has a non-zero digit to the left is going to be significant. So that's why we see 0.230. Those three are going to be significant. Again, we see it here. So these are just different examples. Now, again, these zeros could be significant if, let's say, there is a 1 here or a 2 or anything other than 0. But since there isn't, we know that these 4 are going to be, because this 0 is in between two non-zero digits. And then rounding, again, rounding. This will be the last one that you guys will need to worry about. When it comes to rounding in the following 2, 3 sig figs, again, you got to look at what's to the left of the decimal point. If it's a 3, then I know that everything to the right of it is going to be significant. So 3.00, that's how I'm going to round it up. Again, 5 rounded up to this place is going to be 1. 1 cannot round up to 1 here, so that's why it's 0. When we look here, again, we have our significant digit here, and we have a decimal point, so we know that everything between here and after is going to be significant. So we know that the 2 digits after the decimal point are significant, so it's going to round up to 9.06. Again, when you are rounding up, 5 and up, you round up. 4 and down, you're going down, okay? Looking at rounding up here to 3 sig figs, again, since there isn't a significant figure here or a non-zero figure here, this isn't significant. Neither is this one, but this is. So the 4 is, the 5 is, since the 0 is in between the 5 and the 8, this is going to be our third significant figure. So the 8 is going to round up here, and it's going to be 0.00451. Again, we're not saying what the sig figs are, but we're going to round up to the following sig figs. And again, we see the examples here. So again, look at it, understand how they're doing things. We see here that after this example here, they start to go into scientific notation. And with that, you have 2, since it's to the left, 2.309. But since that 0 is the third significant figure, you're going to round that 9 up there. Same thing here. It goes to 6.00 because 9 rounded up is going to be 1, or it's going to be 10. But that 10 is going to round up here to another 10, and it's going to round up. So you're going to have 6.00. And then since in this last example, 3 and 4 are on the outside and the zeros are in between, you're going to be able to say that the 3 is significant, the 0 is significant, and the 0 is significant. Since it's not 5 or higher, you're going to round down, so it's going to be 3.00. So we will move on to addition and subtraction after the test, but that's a pretty good preview of how significant figures are. Again, you're going to have a lot of practice with significant figures. If you have any questions, concerns, email me, let me know, and we'll work through it together. So that is that. Thank you for joining my Screencastify talk.